Hey everybody, today we're going to solve the letter combinations of a phone number problem on LeetCode. We're given a string containing digits 2 to 9, return all possible letter combinations that the number could represent. So this just basically works like the mapping of an old dial phone. So the way keypads work on phones, 2 ABC, 3 maps to DEF, 4 GHI, and so on. So here's what the input example looks like. So they give 2, 3, and here are all the possible outputs. So 2 can map to A, B, or C. So you see A show up 3 times, B shows up 3 times, C shows up 3 times for 2, and then 3 can be D, E, or F. D, E, and F shows up in each of those combinations. So those are the different combinations that are available. So this is a backtracking problem, and that's how we'll solve it. Any problem that asks you to generate a bunch of different combinations can often be boiled down to a backtracking problem. So let's take a look at the code here. I started out with a map, and what I start doing here is I fill this map with what each number associates to a list of characters. So 2 A, B, C, 3 D, E, F, and so on, just like the picture shows over here. And then we have a list of strings which we will store all the combinations in, and then we just backtrack. So we call backtrack with the string that we're given. We send it in as a char array because that's easier to work with. The initial index into the string is 0, a string builder. I'll explain why we use string builder here in a second. Our solution set, and then the map so it can look up the characters that it needs. And then the backtracking is pretty simple. So if the current string's length is equal to the digit's length, what that means is we've accounted for each digit. So our string has a character for each digit in the input. Then we just add that to our solution set. And down here, we start at the index that we're given, so the index into the string, and we go up to the string's length. And then for each character that certain character could map to, we add it to the string, we backtrack from the next index, and then we delete that character, okay, to remove it. This is a really common backtracking way of solving problems. So basically the string builder is acting as a buffer here. And what we're doing is for each character in the input string, we go through each character that digit could map to. We stick it on the end of our buffer. We append it. We backtrack with it appended onto the string. And then when we're done working with that, we remove it. Okay, we remove it. So we return the buffer to its old state. So we can consider the next possibility. So that's a pretty common way of solving backtracking problems. Alright, cool, so it works. So this is a pretty good problem to start understanding how backtracking works when you're generating a bunch of combinations here. So again, all we did was we figured out what our starting state was. We set in the string. Oh yeah, and I said I'd explain why we're using string builder. One thing I found is when you're appending and deleting from strings, it's a lot faster to use a string builder than it is a traditional string, in Java at least. So that just saves some time there. But yeah, so we send a string in. If we hit the length, that means that we've accounted for each digit in the input. We add it to our solution. And then for each index from the starting index that we're given up to the length, for each character that digit can map to, we append it to the string that we're building. We backtrack from there, and then we just remove it to return the string to its original state.